here's some other jargon that you really need to know. And it has to do with the shape of the distributions. And this is something called skew. And when we talk about skew, we're just talking about where this, we'll call it a hump, where this hump is located. In a normal distribution, there is no skew, and that's because the hump is found right smack dab in the middle here, and we would say there's no skew. We actually have a way to calculate skew. We would say here, skew, if we calculated it, skew would equal to 0, no skew. But sometimes the hump can be found off here. It's been like pushed over to the right side, and we would say that it's skewed if that happens. And then similarly, maybe this hump is going to be pushed over here to the left side, and when that happens, there is a skew. All right, so let me illustrate what those skews are. All right, so this one, if the hump is pushed to the left, we call it a positive skew. Now you might think, wait a second, shouldn't that be a negative skew because the hump is pushed towards the negative end, right? If you think of a number line, it's pushed towards the end. And the mnemonic, the memory trick that I came up with to help you remember is this handgun analogy. So if you were to make a gun shape out of your hand, where would the gun be pointing to? And it's pointing to the positive end of the number line. And this represents the hump, right? So if you were to line your finger gun here, line it up, let's move this over to here, you would see that this would be your thumb, and this would be your index finger, your pointing finger, right? And it's pointing to the positive end, so that's a positive skew. Now, another way we can describe this is to say that in this particular distribution, most of the people score at the low end, and very few people score at the high end. Okay, so the majority of scores here are at the lower end, and fewer score at the high end. In fact, with a distribution like this, if it's a very strong positive skew, we would say there's really no tail here. There's only one tail, and it's at the positive end. All right, and if we were to calculate the actual skew value, we would get a positive number to reflect a positive skew. All right, and the larger that number, the more skewed it is. So if we had a positive, I'm going to say this is positive 5. Just, I'm making up a number here, but it's positive 5. All right, now, if the hump were pushed even more towards the low end and dropped off really quickly, that might increase the skew value to positive 10. All right, so you see that if your skew value is positive, you know you have this basic shape where the gun is pointing to the positive end of the number line. And the larger the skew value, the more skewed it is. This would be a negative skew. And again, you use this handgun analogy. Here's the hump. Your thumb is the hump. Here's where your pointer finger is, and you're pointing to the negative end of the number line. Okay, so that's a positive skew. Another way of saying it is most of the people get high scores with very, very few people getting lower scores. So now let's see if you've understood this. Certainly after everybody in the class takes their first test, I'm going to get a shape for the distribution of the test scores, right? Maybe it's going to look like this, a normal distribution. All right, so we're going to put test scores down here, and we're going to put the number of people getting into each category of test score over here on the y-axis. So this is frequency, and these are your actual test scores. So it could be this, but maybe it's this. Maybe it's going to be a positive skew. Maybe it's going to be a negative skew. Let me ask you, which one are you hoping for? Look at it. Which of the three? Well, hopefully you said this one, negative skew, because that means that the vast majority of you are doing really, really, really well. And then there's very few people who are not doing well. Now, we'll add something to the what do you hope for? You're hoping for this, and you're hoping that you're right here, right? Wouldn't it be nice to be right there? Well, some of you will be. Hopefully, though, none of you are here, but, realistically, in every class, there's almost always somebody, one or two people who are really struggling. And it's those people in particular that need to be contacting me so that way we can take you from here and help you climb over to this part of the curve. Okay? All right, another thing that we can look at when we talk to one another, another piece of jargon is called kurtosis. Kurtosis to me sounds like some sort of disease, like, oh no, you have kurtosis. All right, but it's another good Scrabble word. Here's the thing though, when I play Scrabble, quite honestly, the only words I ever think of are things like house, cat, dog, car. I never think of words that I have in my vocabulary, like statistical words, that might get a lot of points. And I'm going to throw some even better Scrabble words at you. You just have to remember how to, when to use them. Okay, so besides being a good Scrabble word, what does kurtosis mean? Well, it's a term that we use to describe how pointed or flattened the hump is in a normal distribution. I should point out, let me go back just one more here. I want to make sure that you understand this is a normal distribution. This is not normal. This is skewed. So if you have a skew, we wouldn't call it a normal distribution. We would say it's a skewed distribution. Same thing with this one. Okay, so only this is skewed. When we talk about kurtosis, all of these are bell-shaped, and all of them are symmetrical. So these are all normally distributed. These are normal distributions. It's just that some of them are very peaked and others are flatter, right? But they're all normal. So now, if we look at this black line here, that represents what we typically think of when we think of a normal distribution. In other words, it's not too pointed, it's not too high here. We would call that leptokurtic. If it's more peaked than normal, it's leptokurtic. And it's not particularly flat, which we refer to as platykurtic. If it's right in between what we normally think of when we think of that normal distribution, we call this mesokurtic. All right, so I think the word's going to pop up in a minute, but just for now, we call this mesokurtic. And again, if it's more peaked than normal, we call this leptokurtic. And if it's flatter than normal, it's platykurtic. And now I have some ways to help you remember. Okay, so this one, leptokurtic. Well, if it's more peaked, right, it goes up higher than the normal mesokurtic shape, then you have to leap over this distribution. It's really high, you're going to have to leap over it. And so that's the mnemonic that I have for remembering this word. So a mnemonic is just a trick to help you remember. So that's leptokurtic. Now, platykurtic, you would think some obvious tricks to remember might be plates, because plates are flat, or plateau, because a plateau is flat. Well, when I was an undergraduate student, my mind didn't work that way. I didn't even think of that. And the one thing that I thought of was a platypus. And that's because platypus has a flat beak, okay? And it starts with plat, right? So platypus, platykurtic, that's what I thought of. So, you can use whichever mnemonic you want. I would encourage you to think of a mnemonic, a trick to help you remember. But if you want to use the platypus, feel free. It worked for me. Now, mesokurtic, the mnemonic I have for that is that it's in the middle. Meso, middle. Okay, mesokurtic.